Okay, let's do our example for the log-log transformation to show you the difference comparing to original model. And here we go with the data where I adapted from a professor in Duke University, and this is a source. And we are doing a linear regression model for weekly bear sales, and Y being the cases sold for 18 packs, and X being the price per dollar. And this is how I read data in and attach the data set so that I can refer the variables directly instead of use this beer data set with dollar sign and the variable names. So this is just a small trick. And a standard approach is to model this price versus quantity sold with log transformation on those variables. But we just want to make a comparison here. So we do it on original scale first. So we always plot a scatter plot first before we create a linear model, like here. So this is how our original Y and X looks like. Well, this linear regression does not look so good just by looking at this data and how this line fit the data. Let's look at the summary, the coefficient estimate coefficients for now. So this model seems to tell us that for the 18 packs, for every $1 increase in price, we should expect to see about 93 cases decrease in sales. So this is a negative, so it's a decrease. Well, this is based on a model that does not fit the data so well. Well, it can be verified by looking at the diagnostic plots. This residual plot looks okay, but pay attention to the variance. The variance like this, for this area, the variance is much smaller, right? They did not spread at all, almost concentrated in this small area. But for this area, it's much more spread out. So non-constant residual variance. So not good. This standardized residual, for this normal QQ plot, we have some outlier issues here on both tails of the QQ plot, and some kind of trend here, non-constant variance as well. And unfortunately, there's no outliers here. See, I said this, the bad news is that there is strong evidence that the model does not fit the data well, and the variance of the errors is not constant. So this is a situation where we want to know the price elasticity, and we should take the log transform of both X and Y. Beside this non-constant variance issue, and for this data set, and we're interested in this price elasticity. So this log transform would get us to it. And hopefully it will also help us solve some of the non-constant variance issue. Let's take a look. So here by the way, the data set have already included the log transform data with this underscore long for both X and Y. So we do a scatter plot first, but it is a different see. And also I add the regression line to it. Well, this one looks much better comparing to before, right? The data kind of evenly distributed along this line, right? And check the diagnostic plot. The variants are much more like stabilized, and there's no particular pattern. Yeah, seems like not much of the pattern. And the normal QQ plot is getting much better. A bit of off on the tail, but much better compared to before. Similar here, and no outliers. So, well, this diagnostics are not great, but we'll look at that later. For now, they're better than the original model, right? So now we get our new interpretation with this log transform. So it is for a 1% increase in price, we expect to see a 6% decrease in the number of cases sold. So it's 6% decrease. Well, there shouldn't be a negative. So, well, this is the interpretation with this log transformation. And let's look at a prediction interval comparing to the original model. Let's do the prediction interval for the original model first, where I get a sequence of our x values and do a confidence interval for a sequence of new x values. This new x. But this is how I do a prediction interval for the new data. 95% confidence interval, by the way. And we plot the data with a regression line in blue, and also add the confidence interval in this prediction interval that I named it as conf int y. Added this prediction interval here. Well, it does not look very good. It did not even cover the data at all. Well, let's do it with our new model, the beer log, and similarly, I put a sequence of new x and get the prediction interval, 95% prediction interval. And transform, because we use the log model, we have to transform it back to the original unit. So this is the key line to transform back to the original scale. And also this x also got transformed back, and this is a line out of, well, this is for, sorry, this lines is for the confidence interval. Oh, sorry, this is for the predicted value as in the middle, and the confidence interval and the prediction interval are plotted with this command and showing as here the upper limit and lower limit. And this one looks much better. Well, it covers the data well, and it's getting narrower when the data are more concentrated closer to each other. So the new prediction interval fits the data much better, and this is the see this blue line is the fitted value, where the upper limit is this. Well, this is upper limit, this is a lower limit, and these are basically plotted on this plot.